Hey, it's Mr. Allred, and we are still simplifying rational expressions, which means simplifying fractions with variables in the denominator. The problem we're about to do is dividing fractions. So just as a reminder, when we divide fractions such as a over b divided by c over d, most people remember keep, change, flip, where we keep the first fraction, a over b. We change the division to multiplication and we flip or take the reciprocal of the divisor. So that becomes d over c. So this usually becomes a over d, ad over bc. So let's look at the fractions we have, because the simplification process is probably going to involve a lot of factoring. But the first fraction is numerator x squared minus 6x minus 16 divided by denominator x squared plus 4x minus 21. And that whole fraction is divided by the fraction numerator x squared plus 9x plus 14 over denominator x squared minus 8x plus 15. So the first thing we should probably do here is just kind of remind ourselves that we gotta keep, change, flip. So let's just go ahead and rewrite it. X squared minus 6x minus 16 over x squared plus 4x minus 21 times, and we're going to flip the second fraction. So on top we'll have x squared minus 8x plus 15, and the bottom will now be x squared plus 9x plus 14. I got messy. Okay, well, I clear that up. So we got to factor all these things to see if anything cancels out, and they're not hard to factor these. So let's take them one by one. X squared minus 6x minus 16, I believe that's x minus 8 times x plus 2, and you can factor these the long way, but just to save time I'm going to do it the short way in my head. That denominator, x squared plus 4x minus 21, that looks like x plus 7 times x minus 3. Okay. The second fraction, x squared minus 8x plus 15, that seems like x minus 3, x minus 5. And x squared plus 9x plus 14, I think that's x plus 2 times x plus 7. So it doesn't look like everything or very much at all is canceling out here. A few things. There's an x plus 2 on top and bottom, and there's an x minus 3 on top and bottom. Other than that, it doesn't look like it cleans up a whole lot. So I'm kind of going to leave things factored just to show that we can't cancel anything else out. But on top we can have x minus 8 times x minus 5. And then on the bottom, since they're both x plus 7, I'll say it's x plus 7 squared. The drawback to multiplying all that out is that somebody who comes behind you and looks at it is not sure if anything else will cancel and would have to do the work to factor it to find out. So that kind of just saves some trouble. If we need it back together, we can put it back together later, but not doing it up front. Okay. The next problem, it says simplify, but it's adding two fractions together. So just a reminder, let's remember how we add two fractions together. We might want to add a over b plus c over d. And remember, we need common denominator to add fractions. So b and d are the two denominators, so we would have a over b times d over d in making this common denominator plus c over d times b over b. And now that the denominators are the same, we could write it as one fraction, which is part of our goal. The denominator would be bd. but the numerator would be AD plus BC or something like that. So we just need to make sure we have common denominator so that we can add these two fractions together physically. So let's see here. I'm going to rewrite them and leave some room. So the two fractions are 3 over x plus 4. And then we're going to add to that 2 over x minus 2. So the two denominators are x plus 4 and x minus 2. So both the fractions must have that in order to combine them. So the first fraction, 3 over x plus 4, needs an x minus 2 in the bottom, so it must also have an x minus 2 in the top. The second fraction, 2 over x minus 2, needs an x plus 4 in the denominator, so I must also put 1 in the numerator. So when I multiply to make a common denominator, I'm going to multiply by 1. So I just change the way the fraction looks, but not the actual value of the fraction. So let's see here. I'm going to do some cleanup. This first fraction, or multiplication of the first fraction. I can take the 3 times the x minus 2 and have 3x minus 6. And from the second fraction, I can take the 2 times the x plus 4 and have 2x plus 8. Now the two denominators are the same, and I'm going to leave them factored just in case something appears to cancel later. So the x plus 4, x minus 2 is a common denominator and will just be there. So as I add the top together, 3x plus 2x will be 5x. And negative 6 plus 8 will be plus 2. So that would be my numerator. My denominator will be x plus 4 times x minus 2. And once again, it's obvious that nothing else will cancel or reduce. But I'm not going to multiply it back together because it might hide that fact. So we've created now one fraction and canceled out everything we could. The next problem is subtracting two fractions, and we subtract fractions just like we add fractions. It's just a subtraction, so we need common denominator. So a over b minus c over d, if you go back to the addition of fraction rule we just had, should be ad minus bc all over bd. Okay. But in this case, we've got something a little bit more complicated, and we'll see. We're subtracting the fractions, and the first fraction is numerator x, denominator x squared plus 4x plus 3. That's going to be minus the fraction 3 for the numerator, and the denominator x squared minus 4x minus 5. Now, the interesting thing here is both of these denominators can be factored. And if that's the case, it might be a good idea to go ahead and break them down before we get too far into the problem. Because they might already have something in common, so I might not need to multiply both of them by a quadratic. So the first one, x on top, the x squared plus 4x plus 3 in the denominator will factor into x plus 1 times x plus 3. Now I'm going to leave some room where I can complete that fraction and make a common denominator. But it'll be minus the second fraction, which is 3 on top, and then that denominator of x squared minus 4x minus 5 will factor into x minus 5 times x plus 1. So both of these fractions already have something in common in the denominator, so I don't need to multiply by an x plus 1. So let's see, the first one is missing an x minus 5 in the denominator. So I'm going to multiply top and bottom by that. And the second fraction is missing an x plus 3 in the numerator denominator. So I'll multiply by that. So let's see. In cleaning this up, the numerator of the first one will be x times x minus 5. So that's x squared minus 5x. And then the second fraction, the numerator will be minus. And then it'll be 3 times x plus 3. So that'll be minus 3x minus 9. And we've got all these denominators, x plus 1, x plus 3, x minus 5. So let's see, I'm going to combine like terms in my numerator, x squared minus 8x minus 9, all over this same denominator, x plus 1, x plus 3, x minus 5. And the interesting thing here is this numerator, this quadratic, will actually factor. So x squared minus 8x minus 9, I believe, is x minus 9 times x plus 1. So this is why it would have been counterproductive to multiply that bottom together. One, it would have taken some time to multiply the three terms together. And then we would have missed the fact that we can throw an x minus 1 out of the top and bottom away. So when that simplifies, my numerator is x minus 9 all over denominator x plus 3 times x minus 5. So now one fraction, no factors that will reduce. And if I leave it factored, then it's pretty obvious that it won't reduce anymore.